For coming, Julio.
Thanks to you. So, well, my name is Julio Rabada, as Irene introduced me. And what I'm going to do here today is just to try to explain what is the citizen science. And we are going to focus especially in the observation.org platform, that it's a platform. It's a combination of tools of citizen science. And I'm going to try to focus on what can this platform do for you as a scientist or researchers. So we are going to begin. And well, citizen science. What is citizen science? Basically, is the combination of the people, the collectivity of citizens, collaborating in scientific studies. There are some conditions or rules. The first one is that the citizens are not the test subject, so we are not going to study the citizens. And all this work and collaboration has to be under scientific supervision, basically because a guidance is needed for this. Usually, we will need a large group of volunteers. This is something we will try to explain later with some examples, but basically, the large quantity of people is the power of the citizen science. Also, the key in the success of a citizen science project is that usually we have participatory science between scientists and citizens, or we have distributed science. We will explain this later. So, a little introduction about the history of the citizen science. At the beginning of the citizen science, we can think like citizen science being something that happened just some years ago, but that's not true. Basically, what you need is people with free time, and that was the situation when the first scientists came to work and being a real scientist. For example, Linnaeus made most of his work using a network of volunteers, not as a main work, but in his free time. So that was like something like the first example of citizen science. It's a collaboration between volunteers that are not experts and one expert that made this network, that made the taxonomic classification that we have nowadays. And also another example of citizen science base is the annotations of hundreds of hunters, millions of hunters, farmers, and fans that go outside to the nature and has been taking information for years, hundreds of years, and we have that information there. So it's like the very beginning of this collaboration between citizens and science was a long time ago. There is a lot of projects nowadays using all-time data that are getting very good results. For example, if we want to put some point in the time to make, this was the first big event of the modern citizen science, we can talk about the Audubon 1900 Christmas bird count. That was the first attempt to create a network of observers on the field, coordinated for one aspect, focusing in one aspect. So usually when the people go back home in Christmas, they used to hunt with the family in the States. So the Audubon Society proposed a campaign of observe all the birds that you can during those days and send your annotations to the Audubon Society. So they made like the first networks of bird observers during that Christmas. And it's something that it's still being doing for 120 years. And that was like a milestone that changed everything in this history of the citizen science. Because the change was to make hunters observers. So that was something, a key for a change, a real interesting change in citizen science and the observation of the nature. The consequence of this bird count was that they have the first national meeting of ornithologists, and they created that network. They used they don't have the technology that we have today. They don't have mobile phones, so all the information was sent using the snail mail. So it's not a quick network, but it worked. And that created a routine of going outside and count things. So people began to count, and they began to compete also, counting birds. And I think it was at the beginning of the first, of the big war, that they got one guy that made 100 bird species in one day. And that was the big day. I don't know if you are used to this terminology, but to have a big day is to see a lot of species in one day, and have a big year is to try to see as many species as you can in 1 year. That now it's very popular among ornithologists. So, as a consequence of all these, people were interested in just observing the birds. A guy, Peterson, maybe some of you know this name, published the first American guide just to identify birds using your eye. You don't have to kill the bird. You can go to the countryside and just try to identify the birds, looking at them. And there was a lot of history behind this. So at the end, we have all these traditional citizen science projects that is like the present of the traditional citizen science. Now we have a lot of people collaborating in many projects. I have included here some Spanish projects from two of the main societies studying the nature. We have SEO BirdLife with a lot of programs, and SESEM with also a bunch of them. And well, this is done basically using the terms that we have defined at the beginning. We have a lot of people collaborating with scientific supervision, taking data, mostly of the time in paper, and at the end you send the data that you have collected on the field to the central for revision and collection. For example, here in the EBD, there are some people doing also citizen science with collaborative bird bandings like the greater flamingos bandings or the black-necked grebes. There is a lot of people collaborating in this. Not necessarily just collecting the data, but also helping to collect the data. Well, nowadays we have technology. Everything has changed. We don't have to use the pony mail anymore, and we don't need the paper. We have internet. Woo! It's low cost. It is everywhere, and the data is very easy to send or to receive. You don't have to pay anything for it. Also, now we have the power to manage a lot of information. We have big data. You can gather the information, manage all this information, and you can keep it under control. For example, the Hubble took 1 million images during its lifespan. It's still working, but, well, 1 million images is a lot to process. And you have to take all that information and extract knowledge from it. Well, that was the Hubble, but now in observation.org we have 22.8 million images. What are you going to do with 22.8 million images? Well, that's nothing. There are much more information on the internet. But other aspect that is very important to the evolution of citizen science is that we have a cognitive superpower. We have time, spare time, free time, and we have abilities that we can use during our spare time. And of course, we have crisis budgets, and this is an eternal crisis. So we have, with this combination, to find a solution to the citizen science, and technology has came to connect the dots and create a very good solution for not the future, but the nowadays citizen science. So, some examples of citizen science are, for example, the first level of citizen science is the set and forget. Basically, the user, the citizen, does nothing. It's passive. For example, we have some projects that basically you have your mobile phone or you have your computer that it's doing nothing during a lot of time. You have CPU cycles, CPU time. It's wasting. You're wasting electricity, but your computer is doing nothing. So what you can do is instead of having a screensaver, you can run an application in the background that is making calculations. At the time you move your mouse or you begin to write something, the application stops. But just in the moment you stop doing something with your computer, it began to calculate something in the background. This is something used in some programs like SETI at Home or Einstein at Home or RNA World that are trying to do the same things that is done in the supercomputers. But basically you have a distributed networks of millions of computers doing the same. In a second level, we have the web apps where the user is active now. So you have to enter, you have to check some data. It's not data that you have collected, somebody took it. And you're helping to process that data manually. You review something, you do some evaluation of the information, and then with a lot of other people doing the same, you are solving a problem or you're doing something that it's impossible to do just for one team of researchers or any company. It's a work that requires a lot of time. For example, we have the malaria spot application that is trying to locate the infected cells in the blood with malaria. You have a lot of samples, you are reviewing photographs, and you are trying to locate the cells that are infected by malaria. Also, you have the Old Weather project, that it's a project that you take all the logbooks of old ships. You have a lot of information there about the climate, but you have to go there and review one by one, try to search the temperature, winds, etc. Or Zooniverse, that this is a very big project involving a lot of more projects for image ID, transcriptions, images, etc., etc. So now we have, the third level. You are doing something more just to review previous information. You are collecting information. How? Passive. You are not doing anything just but use your tools. You have your mobile phone in your pocket, and for example, with this application, the CrowdMag, you are trying to follow the changes on the Earth magnetic field just using the compass that you have in your mobile phone. I don't know if you know it, but you have a compass. Everybody has a compass on the pocket. So you keep it running in the background, and it's collecting information that it's sent to a central, and they can process it later for anything. And the fourth level, that is the level we are now going to focus after this, is the active level. Go out there. You are the sensor as a human, so go out there. And you can use the technology to collect the information and send it quickly to a database, and that database can't be an Excel sheet or an Excel sheet. It has to be a normalized database where you can process everything quickly and everything ready to be analyzed. So as an example, we have a lot of platforms here. We have iNaturalist, Natosfera, Ornitho, eBird, that is the big one in birds, Mosquito Alert, or CyberTracker. Some of them has particularities that made it more useful or less, depending on your interest. But I'm here to talk about my book, that it's observation.org. Okay, so I have tried many of these ones. I began to collaborate with observation.org 4 years ago as a user, and I get more and more involved in the projects, and now I'm the coordinator of the platform here in Spain. But basically, it's a process that has been naturally evolved to be here as a citizen. I am not a scientist, really, when I'm talking about observation.org. So, under my experience, there is a lot of models that it's something very important when you are thinking about citizen science, is that you as a research team or a scientific team, you want to use citizen science. Observation.org is a platform that came from the bottom to the top. We are users that wanted to use technology to improve our experience collecting data on the field. But sometimes you are a research team that want to go to the users and do something with citizen science. So the key here, under my experience, are the citizen science communities. It is something that you have to keep in your mind. You need the people, and you need to get to the people. So what is better, the egg or the chicken? So if we got the chicken, imagine that you are a scientific team and you have project. A project you need, for that project, you need money, of course, usually as much as you can. And you want to create a citizen science project, so you need the citizen science platform, a collection of technological tools. You need mobile applications, you need web pages, databases, etc. That's a lot of work, and you need a lot of money. Once you get this, you need to communicate the idea and the project to people and engage people to your project. So you have to spend a lot more money in communications. Okay? You get it here. Then you got the data. The information is collected by your community, that it's back to you so you can analyze it and do the thing with your project. So you got the ideas, you got your papers, etc. What's the problem? That this has a lot of risks because your chicken, that is the community that is providing you the data, this may fail because you don't have reached the people in the way you wanted, so you have no community. If you have no community, you have no data. If you have no data, you have no results. So you have a sad scientist. Well, the thing is that the key is that you are trying to create a citizen science platform by your own. If you think of the community as the egg, you have a community that has its citizen science platform. They are producing data already. There is a lot of people collecting information out there. And you can use the information directly. You don't need to pay anything for it. It's already there. So you can now create knowledge, new knowledge, using the data that some people are collecting for free, just for fun. But also, the thing is that you can create a project, help or engage the community that it's already there doing the things, so you have new data or more focused data on your project. Usually, this is in the order of 1,000 times lower in cost, in terms of cost, than the previous option. And we have happy citizens, and everybody is happy here. I think this is the model of a success. If you try to follow the previous model, you are losing, you are getting a lot of risk because you're losing the power of the community. That is the community producing data. And you're spending a lot of money that probably you don't have. So this is something that I want you to keep in mind. There is a lot of people creating projects, spending a lot of money in technology, in new platforms, but nobody is using it. And that's a waste of time and money and effort. So what is Observation.org? Observation.org is a community of citizen science. It was born in 2005 in Netherlands. And now it has evolved as a platform, international platform, that obviously it was born in Netherlands, jumped to Belgium quickly, and now is the main citizen science platform in Europe. We have 140 million observations and more than 2,000 observers, 200,000 observers, sorry. We are also in Spain, of course, France, Austria, Switzerland, Germany, some presence in Portugal, and we are the partners. There is a big project here in Europe about birds, that is the European Bird Portal, and we are the partners that brings more data to that project. Mainly because Holland, Netherlands and Belgium, they are mad. They are all the time on the field collecting information. It's amazing. So, in this platform, you can register everything, any life form, from an algae, a bacteria, or a bird. And it works worldwide. So you don't have to worry about, I'm going to travel to Japan. May I use the platform? Yes, you can use it anywhere. And our mission is to encourage people to collect information in the nature so they can take all this information easily to a database that is going it is going to be a big reservoir. It is a big reservoir. And we try to keep everything under revision, updated, and easy to use for future generations to get something from that information. As I said previously, we have 140 million observations. We have more than 200,000 users. We have information about 80,000 species. A lot of pictures. This number is wrong. This one is a 2. And we are working together with more than 250 work groups. Some of them are research teams, or other are just associations and societies. This is the growth of the platform in Netherlands. This is the number of active users collecting information, and this is the number of observations per year. This is something that we are trying to get. Maybe in 10 years we can be like the Netherlands. They have a culture of going outside and looking at the nature, something that is not happening here in Spain. So we have to also look at the cultural things. And this is the platform at some point in 2008 went international. It was not only for Netherlands, and it's growing more or less in the same way. And this is my part. We have been working in Observado, España. Observation in Spanish, Observado is the name we are using here. And since 2015 is when we are working locally with the platform, so we are growing rapidly. This green part of the bars are the observations made by Spanish users. So I think the progression is interesting. In these 5 years working here, we have reached these 2 million, almost 2 million of observations, 14,500 species, and we have collected information in 6,500 areas because we have our database structured geographically, so we can identify the number of areas that has been sampled. In details, observation.org tried to be a complete solution. So you can record any species, as I said previously. You can include images and sounds attached to your observations. And so you give more data to your observation. It's not just, I've seen this. No, you can attach the proof or something that can be used in the future for something more. And you can take all this information directly from your mobile phone. You don't have to use paper anymore. Well, sometimes you have to use paper. You go to the toilet, I recommend it to you. But now the paper is used only in few situations in the field. And the mobile application is so good that you can use it even if you are a professional on the field, doing field work. Attached to all this, with all that information that we have collected before, we have developed an auto-image recognition system that now is working with more than 14,000 species. This project has been possible thank you to the collaboration with the Naturalist Biodiversity Center, that is one of the partners of the platform. I don't know if you know Naturalist. It's the third natural history museum in the world after the Smithsonian in London. They have a huge collection of specimens, and they have photographed everything. With the help of that information and all the pictures that we have in observation.org, we are now able to identify by picture this variety of species. It's something very helpful, not only for the expert, but also for the amateur that want to explore what is in the surrounding. Also, in the big project of observation.org, you can have your small platform for something, or not so small. You can have regional portals for your area of study, or your association. And even you can have projects for some specific species. For example, we have the SESEM portal that is made specifically for the Society of Mammal Conservation here in Spain. It's working with mammals in Spain. So you can have all this information showed in one web page. It's important to say that all this information goes to the same database. You're just extracting a portion of it, and you're working with that portion. Well, basically, you can record everything, any kind of observation, not only of every species, but we have thought about it. You may be interested in taking only roadkills, or you want to use your tool for observations or doing censuses or transects. You can use it. We have the database prepared for that, so you can go outside to the field, activate the transect mode, and now it will record everything and will help you to do it. Also, if you are thinking about a citizen science project, engaging people to take data, this platform is very helpful to record something that it's sometimes overlooked in other platforms. That is, you can get the sample effort very well. Also, our focus is in protection. So we try to preserve individuals and species that can be under some, I don't know the word, can be under a menace. You want threat. Sorry, it went away. So you can decide to hide some observations. If you want to share them, you can do it sometimes. If you want to hide it, you can do it. But also the platform has some filters to avoid some information going to the public. Also, it helped you. We help you to identify some species. If you have doubts about something that you have looked in the field, there is a lot of people reviewing all the observations and trying to find mistakes. And if you ask for help, we will try to identify what you have seen. Also, you have all the information in a database. It's your private database. And you can filter, query, see a map, and see your statistics in real time. Phenology, there is a lot of options that I'm not going to show you here everything because it will take hours, but I invite you to use the platform and try to check it. Well, the good thing here is that we try to preserve as much information as possible from you in the field. So every observation is an observation and is an observation. So we are not collecting lists, we are collecting observations. This is very important very important because every observation has a precise location, a date, and a time. And you can add a lot of more information about the behavior, about the aspect, about the activity of the individuals that you are observing. And once you have entered this information, you can group all this information in lists that can be used for something more. We are trying to engage people to use the functionalities of route lists that are basically transects or point lists that are basically counts. So you have also the relationship between those observations and the sample effort. That is something that it was previously missed using just casual observations. So everything that you got in your mobile phone is sent then to a database with all that information preserved. We don't do calculations that erase anything that you have collected. And because we have all the coordinates of every information, we thought that the best thing is to use a GIS database that is PostGIS, what is behind this platform. So you can query even information using the custom area. If you want to design your study area, you can. And then you will see only the statistics of all the observations that has been made in your study area. For example, we have here the Parque Natural de Doñana. You have here the polygon. You have some quick information. This is what you see when you enter in the page of an area. You see the surface, the measurements, and some list of the number of observation, pictures, sounds, species recorded, the users, the ranking of users. So there are something that you can quickly see if you are interested in seeing something. This is the number of species per month, grouped by species group. And also, you can, the platform tries to generate some heat maps. It's not a real kernel software going underground. It's just a simple heat map. But you, for example, can just check doing a quick query, something like, for example, the Caprolus here in Aragon. And you can play with the filters and just see how the things are going. Is this useful? Yes, it can be used. So I want to show you here a real example. This is a project from one team from here. Suppose most of you knows Eneco Rondo. So they have been studying the movement of the griffon vulture and the Seminarios vulture in the Iberian Peninsula. And they detected that the individuals that they were following avoided totally or partially Portugal. This is something related to the conservation politics. And for this, they deployed a lot of devices on some vultures, and they collected all the information. Well, if you go to observation.org and look at the observations of the citizens, what happened? Well, this is what happened. These are the same species. We have here the griffon vultures, and here we have the Seminarios vultures. If you compare both of the results, are more or less the same. So you can use this information to complete the information that you have from your sensors. We have thousands of people out there taking information for you. And obviously, the information that the team here from the EBD collected has a lot of more quality. And you can extract a lot of more knowledge from that information. But this will help a lot for sure. Or another example is this platform has been used in Belgium for a project that is known Animals Under Wheels, that has tried to detect, it has detected the black point in the road for road kills in Belgium, and now the query, the map for consulting the number of roadkills. It's available everywhere. So here is, for example, the wildlife roadkills that we have collected in observation.org in the last year. We have not engaged anybody to do this. It's just the people. They are on the road and they see an animal that has been killed by a car and they just introduce it. So you have already information there. Imagine what it's possible using this tool with a project. So when you have all this information and some scientists really interested in getting something from it, you have papers. We are producing, or we know, I am not, but some people out there are producing over 100 scientific publications every year using information coming from observation.org. There is a lot more other platforms and there is a lot more papers going out there. This is just an example talking about what the people has done with our information, but citizen science is useful, it's really useful. So how to use it? Well, you are in the nature and you are looking at something. So we try to do the things very easy. So you have two mobile applications, one for iPhone, another one from Android. The names are different because at the beginning this was a volunteering project. So these mobile applications was made by volunteers. The IOPS and the OPS web applications were done by volunteers. And the other option is to use a web form. So you have collected some information in the field, still using paper. And now you are at home and you want to put all the information in the web page. Well, just using a simple web form, you can put anything on it. If you have old observations from your young years, you can also use this web form to introduce it, or there is a bulk import option if you have something more or less structured in an Excel data sheet or something like that. So in the mobile app, it's very easy. It does almost everything for you. You have automatic data, date, time, and position. You can take pictures with your mobile phone and include it in the observation. And also, you can enable directly the automatic identification of the species if you want it. And for the project that we were talking previously about the roadkills, there was one option that was developed for the Android application. That is, you can use your voice to introduce the observations. That it's very good also if you are working in the field and you have signal. That's the only limitation of this feature, is that you can use your voice. You don't have to look down and imagine you lose one species, meanwhile you are trying to annotate everything. And you can use your mobile phone also to create the list and the transects, because you are moving. It will record your route, and you have all the information added directly to your route, so you can download all the things structured directly in the web page. And you can use all these without network or Wi-Fi, with the exception of the freehand functionality. You can be in the middle of nowhere, you don't only need the battery. And this tool has proved to be very useful, not only for the amateur observer, but also for the professional. And it is an excellent digital field network. Seriously, I've been using it for a lot of occasions, and it's very good. A happy user is Jose Luis Tella. I'm sure most of you know it. He has been using the tool on the field in Sri Lanka, in Brazil, and many others. He has been an active user as an observer, but also as a scientist. If you have any questions about how is the point of view of a scientist using this tool, probably this is one of the best persons to ask. And he is very happy. Also, introducing a lot of old information. That is something that I love. It is one of the best things that once you have finished your field work, you don't have to go back home and begin to transcribe everything from your notebooks to the computer. Of course, this is not useful for all the fieldworks. It's only for those that fits in the kind of information that you can collect with this tool. That is the limitation. But in the case you can use it, that will save a lot of time. For example, José Luis has introduced more than 20,000 observations of almost 3,000 species all around the world. He is mad about the tool. So some people ask me always this, well, you have a lot of data there. We have in Spain more than 2 million observations. What's the quality of those observations? Well, we try to keep it in a very high quality because it's the key also of the utility of the information that you are going to analyze. So we have 3 validation layers. We have a manual review by experts, people that have a very good knowledge. So for this, we need volunteers to review all this information. We are now 1,000 reviewers in the world. In Spain, we are around 30 reviewers, but we need more because we are growing. And this is it's an easy work, but we have fields that are totally untouched, like the butterflies or some coleoptera. Also, once you have reviewed a lot of observations manually, you have another layer that tries to validate automatically some observations based on the previous data that has been validated. And at the end, we have users reviewing observations because you are checking information and you can send a warning to the reviewer saying, this is wrong, I think this is another species, so there is an interaction. Also, we have some kind of poll systems. So once a lot of people has warned about one observation, it may even be being marked as a wrong observation. And we have tools for this to make the reviewers' lives easier. We have our list filters that help us to detect all these wrong informations based on some parameters that we can adjust. And also, we review every photograph and sound that it's sent to the platform. Another concern is the conservation of the species that the individuals that we are observing. So this is totally mad. We automatically hide from the public observation of threatened and sensitive species, and some of them that may be under risk. For example, if we have an observation of an eagle nesting, we hide that information automatically. Another example are the lynxes or the bears. We hide them automatically. We don't want to have a horde of people trying to photograph or find a lynx or a bear in some place. Also, we try to communicate that some people have seen a lynx, but we can put some levels of distortion of that on that observation. So we have like a 5-kilometer blurring. So you can access the observation publicly, but you can see the location or the name of the area. And from this lower level, you can go to the top level. That is, you can hide the observation totally. This is from the point of view of the conservation. Okay? I think there is one more missing. Yes. So now at the end, we have, with all this information, we're trying to collaborate internationally with other projects like this one. It's the European Breeding Bird Atlas. That has been a huge effort to put all the information that is divided in many other citizen science platforms along Europe. People in Italy is using Ornitho. People in England is using BirdTrack. People in Finland is using another one, I can't remember. Mainly here in Spain, people for birds are using BirdTrack, so eBird. So this project has tried to put everything together and collect all that information for creating the European Breeding Bird Atlas. They have created another platform that it's the Eurobird portal, that it's like a child from the previous one. And we are integrated with this platform. We are sending around 14 million observations per year automatically, just going there. And also, we are sending all the information to GPIF, almost in near real time. Not all the information, because as I have said previously, everything can't be publicly seen, so we have our filters. And, oops, you are not supposed to be here. And if you want to access all the information, it is very easy for you as a scientist. You only have to write an email, and I will send you all the data sets that you want. As long as you are involved in a scientific project or in a conservation project, we try to collaborate with also local administrations and scientific teams. So it is very easy to have access to it. So thanks for your attention. And this is our emails. If you want to contact me or to contact us, you can do it through this email. Thank you a lot.